I am using this image copy for the practice and all. This is the image copy, Cloudera Manager. So their window looks like different because they are using, Mapr is using Mapr control system, which is used to manage this cluster, manage the single node cluster, Mapr and heat mapper. Those are the tools provides the interface for you, the web interface for you to manage the Hadoop cluster. Cloudera Manager is the web console for managing the Cloudera cluster. Okay, and then for Hortonworks they are using their own tool called Ambari, which is an open source tool. Even IBM Big Insights also using Ambari to manage the Hadoop cluster. Okay, so different distributions will use their own the front end tools to monitor the Hadoop cluster. So you don't need to do anything from the command line interface anymore in future as an administrator. Everything from this browser. You can manage the entire, see all these like home, services, host, activities, diagnosis tools, audit charts, and then administration. In this administration, you will be everything, including purpose, security, and everything, creating the users, roles, everything, configuring the alerts. Okay, so everything. So importing and the data transfers, data migrations from one environment to other environments. So everything that can be done using this. Okay, so web consoles, not anymore, you don't need to remember the commands and type the things from the command line, Linux command line. That's why they made it easier for the Hadoop cluster administration by providing these front-end tools. So in the real-time cluster also you will see for the same version. So 5.7 is little different, I will show you in next classes. 5.7 is little latest, that Windows changes, the front-end window, and then more like you can monitor the cluster status, how much memory is getting replaced, okay, and what are the storage space available, everything through graphs. When the cluster is up and running, when the cluster is up and running, you can monitor the status of your Hadoop cluster as a whole, the entire cluster, what is the cluster utilization, so that you can add some more storage space. You can add some more memory because it is taking up all of your memory, all the current processes. So that way, just looking at it a naked eye, you can decide it. I am running out of space, I am running out of memory. So like that. So that kind of graphs and everything will be there in the 5.7. They made it very user friendly, the TV interface. It is 4.7 because it needs lot of memory. Okay, you need at least 12 GB RAM or something like that. Yeah, that's why I upgraded the other machine to build the Hadoop cluster, multi-node cluster on a virtualization software. Okay, and so I built that by increasing the memory size. I increased it to that other machine that I have is 8 GB RAM by default, and then I added another 8 GB for doing the administration and all. Online we can do that only through virtualization only. I can show the others, right? On Linux we cannot show them. That's why. So I upgraded that machine to 16 GB to build multi-node cluster. Yeah, on that I installed the 5.7. I will show you the differences between 4.7 and 5.7 once you install this, and then once you get comfortable. There are no much differences related to development between 4.7 and 5.7. Even 4.7 version of Cloudera is also equivalent to Hadoop 2.0, latest. Okay, so now shall we start 7:42? Shall we start? Yes, yes.
Hi Nagaraju, sorry to interrupt you.
Yeah, yes.
Yeah. Can we install this Hadoop on Red Hat Linux, or only we have to install on CentOS or Ubuntu?
CentOS, usually there is an open source, right? Red Hat means it is a licensed versions, right? So yeah, on this image copy that we are using for our practice, this Cloudera Manager, okay, this Cloudera software, a pseudo mode cluster, okay, that's what I am showing in my screen, right? So that is the cluster, that is the working environment for us to do work, practice on all of the ecosystems. They have provided Eclipse, everything, all the working environment they have provided. All the ecosystems are available. We are using this. Okay, so on this they use CentOS actually. On CentOS because it is a sister, right? If you are comfortable with Red Hat, Ramesh, so you are comfortable with CentOS, right? Because it is a kind of like open source software developed by Red Hat. So that's what we are using this. All the commands in Red Hat will work in here also. So they use the CentOS 6.4 version here.
Okay, fine. Both are similar only.
Yeah, similar only. Yeah, similar only. If you are comfortable with Red Hat, that means you are comfortable with CentOS.
Fine. Thank you, sir.
Yeah. So they are using this CentOS. Most majority, even Hortonworks, so they are using CentOS. Nobody is using Ubuntu. But when you are building the Hadoop cluster, multi-node cluster for your practice, you can do it using CentOS or Ubuntu also. Ubuntu 12.04 also. Both will work. Okay. So this is the Cloudera web console. Like your Mapr is having Mapr control system, a web console, and Cloudera your Hortonworks has Ambari, which is a web console for managing the Hadoop cluster. Okay. So yeah, most of the people are here. So we'll start. It already 15 minutes left. Okay. So we are going to talk about the different ecosystems. Hadoop is kind of a framework, right? On top of it, lot of ecosystems are built. So based on their like the functionality, okay, based on the user requirement, they created lot of ecosystems. Some of the ecosystems will be used for implementing the same purpose, but a different flavors. They will have their different features, unique features for implementing that. And then for the developers, and then the people from the development background, the people from non-development background, they provided they will implement the same feature, same functionality, but different technologies. So for that also we see a lot of ecosystems here. So that's why before talking about the architecture, I will give you overview of each of these ecosystems that you are going to install on top of your Hadoop framework. Okay, based on your requirements, we choose some or more of these ecosystems. Okay, so you can select a shoot based on what you are doing. Okay, select a shoot of ecosystem, some of the ecosystem. For the same project, you won't use all these ecosystems because same ecosystem will be doing multiple ecosystems will be doing the same thing. So based on your environment, based on your requirement, we choose one of these ecosystems as some of these ecosystems. Okay, for implementing end-to-end business process. Okay, so here the first thing, Hadoop is mainly for what we have created this distributed architecture. For what purpose? To meet the challenges of storing the data and processing the data. That is the limitations, right? So storing the data in a distributed way, processing the data in a distributed way, because these are two limitations of the traditional systems, traditional technologies which are based on a single physical server. So Hadoop is kind of a cluster. How do you call it? The Hadoop cluster means, okay, so clustering of machines. Multiple machines will be there in order to help you out in storing the data in a big way, processing the data in a big way. For storing, because in order to meet these things, there are initially when they built this Hadoop framework. So two systems are compulsory, right? What are those? HDFS to implement distributed storage, MapReduce to implement distributed parallel processing. These two are compulsory. When you install Hadoop, automatically those systems are not separately installed because you are storing the data with an intention to process it, right? That's why when you install Hadoop, they made these two ecosystems compulsory. Automatically, HDFS is installed and MapReduce installed, but they have provided when you are installing a separate option to start only distributed the daemons, means the software programs, the daemons to start a specific storage related daemon separately, and then processing related daemons separately. You can start them or all of them at a time, but but both will be coming along with your one installation. That is called Hadoop installation. When you do that, one is for compulsory. Both are compulsory. Why? Because you are storing the data in a distributed with an intention to process it in a distributed way. So both will come as a shoot. Okay, so that's why HDFS, when you install Hadoop, whatever the version that you choose, okay, so you will get both HDFS and MapReduce. Okay, HDFS is for storing the data in a distributed way, and then it has its own file system, a separate file system, When that file system is active, then all the daemons required to all the daemon processes. So when you initiate those, when you install Hadoop and then initiate those processes, like name, name node, data node, and secondary name node is first generation of Hadoop. Okay, so name node, secondary name node, and data node, these are the daemon processes that you start, which are related to managing this distributed storage, HDFS. That's called HDFS, Hadoop Distributed File System. So initial, before installing Hadoop software, that system needs have an operating system, right? And to keep the underlying storage of the files. Finally, your Hadoop data or like Linux data will be stored on file system, right? File system. That's why you need to install Linux, and then you install all the prerequisite software, because in order to provide this distributed environment, these machines need to communicate with each other. So the softwares like SSL, SSS, client and SSH server, all needs to be installed before, and then Java, because Hadoop is written in Java, you need to have a Java 1.6 or above for the older versions. Now 1.8 is available, 1.7 and 1.8 will work on the latest versions. So you need to have that, all those softwares. After that, you install Hadoop softwares, and then your system, your Hadoop is not active until you start those daemons. You install fine, but you have to initiate those daemons, so that you start all those daemons, so that your distributed file system will work. So that when you install the Hadoop cluster like this, okay, you will see all these ecosystems like from the web console, so HBase, HDFS, MapReduce, like this. Okay, so all these daemons, that means on this image copy they have installed all the ecosystems here. So they get it ready for you to do the practice. Okay, so while we are doing the administration, we'll do them separately. We'll install Cloudera Manager. On top of it, we are using that Cloudera Manager. We are going to add all these as a roles, like different ecosystems. We will install all these ecosystems later. Okay, so okay, so when you install Hadoop, automatically your HDFS and MapReduce will come along with that. Okay, so now the HDFS. What is HDFS? When you install it on that system, you have a single system when you are from where you are interacting, right? You can use one of the data nodes or name node, the master or slaves, in order to communicate, or you can use the edge nodes in order to provide the communications in the real-time distributions. Compulsory, you will have an edge nodes. One or more edge nodes based on the size of the cluster. Okay, so that some of the users will be given access to some of the edge nodes. So that from there, there is a that is kind of the client from where you are going to, okay, communicate with the Hadoop cluster, send your request. What are the requests that you are going to send? Storage request and processing request. Storage request means copy a file from your Linux file system to Hadoop distributed file system. So what is the advantage of moving the data to Hadoop distributed file system? That file is stored in multiple machines. Okay, so that's what it will make it happen. Hadoop distributed file system will make it happen to store that file in multiple machines, so that you are not overloading any single physical machine there. That is the advantage, right? So that means the file is divided into small chunks called blocks. Okay, based on the default block size, which is configured in some of the configuration files in Hadoop. Okay, based on the configurations, it will divide that file into a number of small chunks and then spread among the cluster of machines. It uses 3 copies by default, and then you can specify in the configuration files, or you can override when you are copying that particular file. Okay, I need only 2 copies for this file. I need 10 copies for this file. Like that, we can override the default parameters which are configured in the configuration files. Okay, so when you do the installation, when we talk about the types of installations like local mode or like a standalone mode, okay, pseudo mode cluster, and then multi-node cluster, we are going to talk about all those internals. Okay, so that's what you configure. So that means when you the HDFS means what? You are copying a file from local file system to HDFS file system, so that it is stored in multiple machines. When the Hadoop daemons or HDFS daemons are up and running, then only it can do that. Okay, so it will you configure a directory path where it has to store the Hadoop data, local file data and Hadoop data. Local file, you create a directory, right? So you store it here. So in Hadoop also, you create a directories, some directories. It is like your local file system. What are the basic file operations which are supported by your Linux? Most of those commands will work in Hadoop distributed file system. They have written some classes, okay, which your LS is doing. Okay, so mkdir, what mkdir is doing. So that those classes will do the same thing, but it is working on Hadoop distributed file system. You can create a directory, you can look at the files and directories using the ls command. Okay, you can copy files internally from one file system, one location in Hadoop distributed file system to another location in Hadoop distributed file system. You can move the files, you can change the permissions, read, write and execute permissions. All those things that you are doing on a local file system will apply here in Hadoop distributed file system. That means if you are comfortable with Linux, you are comfortable with HDFS file operations. Only the thing is you need to do the practice because you are working with two different environments, copying file from local file system to Hadoop distributed file system. So you are putting the data into your Hadoop cluster, and then if you want that copy again back to your local file system, there is a command for copying that file back to your local file system. There are different commands related to working with two different file systems. Okay, so we are going to talk about when you install the software and we do some practice on that. Okay, so that's what Hadoop distributed file system. A distributed file system that runs on the cluster of commodity machines instead of working on a single physical server like your Linux file system. It is working on a multiple machines. That's what the daemon processes which are running behind the scenes make it happen to store the data in a distributed way in multiple machines by doing the multiple replications based on the configuration that you made in your configuration files. Okay, so based on that, it will put a number of copies to make it available all the time. If one copy lost, or some of the blocks stored on first machine, that machine is dead because the network failure or hardware failure, that machine is dead. So that whatever the blocks which are stored on that machine will be re-replicated to other available live machines by the software daemons which are running behind the scenes. There is no manual intervention. That means here the systems which are using this Hadoop architecture, the HDFS architecture like Hive, which is implemented RDBMS, so that your data is not lost there because internally it is using HDFS. HDFS property is to re-replicate the data so that no disaster recovery is required on the systems which are built on top of Hadoop like Impala. Okay, so which is implements RDBMS concept, and then Hive, which is implements RDBMS concept, which works on Hadoop framework, which is installed on Hadoop framework. Okay, and then you will have Apache drill. So they are also implementing RDBMS. All these ecosystems which are built on top of Hadoop framework. That means internally some of the ecosystems are using MapReduce to process the data, and then it is using all these ecosystems compulsory use HDFS for storing the data. So because HDFS property is to keep all the specified copies, so that okay, if one copy lost, second copy will be there, so it uses the second copy to continue the processing. So your system never dies. That's the purpose here in Hadoop. Even though your RDBMS in the traditional systems, you have to have a standby servers, right, in order to keep the copy. If two systems dies, so you have to do the disaster recovery. That is like a big challenge. Okay, that is a big challenge, and then you experience a lot of the users experience a lot of downtime in there. Here, the thing will happen like that. Immediately after one system data is failed, automatically what are the blocks which is related to that file particularly will be re-replicated to other available live machines. Disaster recovery is done by the framework by itself. You don't need no manual intervention. So no issues of downtime. Okay, so that's what all this will take care of by this HDFS. So when we talk about the architecture, we are going to talk about details about how it is doing that, how it is doing the replications, how it is what mechanism will be there to understand what is happening in the files which are stored in the Hadoop distributed file system. We'll talk about them in a couple of minutes. Okay, so MapReduce. So MapReduce, a distributed data processing model and execution environment that runs on large clusters of commodity machines. Okay, MapReduce, because the data is stored in multiple machines in the form of small chunks called blocks. Where they are stored, okay, they should get processed by using the resources of those particular machines. What are the resources will be utilized for storing the data and processing the data? Okay, so storing the data, what are the resources that we use usually? Storing the data, what are the resources used? Yeah, so storing the data, you use the physical storage space, right? Physical storage space, physical storage space. Okay, so it is using that particular machine physical storage, hard disk, maybe 20 terabytes, 12 terabytes, based on your configurations, HDD. Okay, so the next, the processing related, it is for storage, right? It is for storage. Okay, for processing, what are the resources will be utilized by the system? Processing, what are the when you run some programs, what they need, those programs, what they need, the processors, right? CPU cores, it uses CPU cores, right? CPU cores, it uses CPU cores, it uses RAM of that machine. Whatever the data that you select in your queries or from your program will be loaded into the memory before fed into your program, right? So every time it won't go and look at that hard disk for every IO, it won't do that, right? Whatever the set that you want, it will be loaded into the. For that, you need to have enough RAM to load that data. Otherwise, it has to wait, right? RAM, and then so clock speed related to one system. Okay, related to one system. So related to one system, these are the things required. When you are working on a network, and then port speed also comes into picture in a network. Port speed, number of ports. So how the data can be entered, how fast the data can be entered into your system from the network. When the distributed systems are communicating with each other, all these machines are communicating. Port speed and number of ports also will come into picture, because how the data should be entered, right? Faster. Your processing abilities are good, but you are not getting the enough data from the other machines, so it is slow. So that's why the network bandwidth, number of ports, network bandwidth. When you are talking about a distributed system, in a single system, these are the factors that you consider. Memory, okay, number of ports, network bandwidth, all these comes into picture when you are talking about communicating with in a distributed environment. Okay, they all will be coming to picture. Okay. Okay, so that means, so it is using the CPU of these machines. That these are called the resources. What are the resources? Physical storage space, CPU cores, RAM, and clock speed. When you are running multiple processes at a time, what you need? Multiple cores. Each process will run on one core, right? So if your machine is 24 core, okay, 24 core processor, that means how many processes at a time it will run? 24 cores. So if multiple users are hitting, then they have to wait until these processes are released, these resources are released. So otherwise, in this distributed architecture, what you need, because Hadoop cluster means you are connecting all these machines in a LAN network, so that each machine will be communicating with each other to share the resources. So resource sharing will be happening here. Okay, resource sharing will be happening between the machines. So like your distributed storage, right? One file data is stored in multiple machines in the form of blocks. That means if they are sharing the load in terms of storage, one file data is stored in multiple machines. In the same way, okay, when the processing, when you submit a MapReduce job, you write the Java code or some other code, or SQL query is also MapReduce job implemented. We'll talk about this later. Okay, so but MapReduce job, you write a Java program. Java program is, the MapReduce program is basically a Java program or some other program, right? Which is getting on your Hadoop cluster. So when you write a Java code, that code needs to execute it on all these machines, all these blocks which are spread among the cluster machines. Because one file data is stored in multiple machines. Where they are stored, they have to get processed by utilizing the resources of those machines. So processing resources are CPU core and RAM and clock speed will come into picture when you talk about processing the data. Okay, so that means it has to use all the resources. Sharing of the resources will happen here in this Hadoop architecture. Some of the machines are not doing any active processing because some of the files will be stored on some other machines, some of the blocks, but the user did not submit their jobs at the time, so they are idle. So they are actively looking for utilizing those resources. Okay, so what this machine, my machine is has a lot of blocks. Okay, lot of blocks which are greater than your CPU cores. Then it requires some CPU cores, right? So what happens then? This distributed architecture will ask this machine to acquire some resources from other idle machines and then implement the parallel processing. That way, so all these blocks which are spread among the cluster of machines will get processed by this MapReduce framework. That's the framework. For that reason, in order to implement this, all these process them in a distributed way, collect the output generated by all these mapper instances, program instances, okay, which will process each block at a time and then collect all that input and output generated by this parallel processing, and then do the final processing and finally write the output to your HDFS file system as a result, final results of your processing. For that, this MapReduce concept is, there is a concept that that is created by Google. Okay, so the Google called MapReduce concept, MapReduce programming paradigm concept. That concept will implement this distributed parallel processing by utilizing the resources of all these machines. So the main intention, as long as you have enough resources on the cluster, altogether all the machines, it will utilize all machines resources to process all these blocks simultaneously. That's the concept, MapReduce concept at a nutshell. When you are talking about MapReduce, like I said, the schedule in the curriculum, we'll talk about 12 hours or 15 hours on that concept. I will make it clear. I'm just giving you a overview of this, what is happening internally in this MapReduce concept. Okay, the MapReduce concept, a distributed data processing model. It is a model end-to-end process, right from reading the file to completely, and then until writes the output to the output file system. How this paradigm will work? What this paradigm, MapReduce programming paradigm concept, how this concept is implemented. That's what we are going to talk about when we talk about MapReduce. This is a distributed parallel. Most of the ecosystems on Hadoop will use this MapReduce concept in order to process their queries. Maybe SQL, Fig is using MapReduce, Scoop is using MapReduce, and then Hive is using this MapReduce internally, even though they are separate ecosystems. Okay, not only MapReduce separately that you write the program. Even when you run a query, SQL query, select employee ID from EMP, that is a query for you for Hadoop for Hadoop, it is a MapReduce job internally. A MapReduce job gets generated and then execute against the cluster and then collect the information and give it to you, the front end, as a result of your query. But for you as a from as a end user perspective, it is an SQL query. But for Hadoop, it is a MapReduce job internally. That's why this MapReduce concept is very important, because it will die in future. Why? Because Spark is taking the place in future, might be because some of the ecosystems are compulsorily using Big Hive, because a lot of work is done on that Hive side, because a lot of systems are working on Hive right now. Majority of the clients they are using for implementing the data warehousing concept, they are using Hive. Everywhere you see Hive will be available for warehousing because the reduced cost and lot of other advantages of Hadoop framework. Okay, so that's why MapReduce never die, but basically you might be using Spark, but you need to know. That's why I emphasize more on learning this MapReduce concept at least. Okay, the concept, how this end-to-end process. You are not doing on a regular basis the coding, but so you need to understand the concept, how it is happening. Okay, so that's what the MapReduce is about. That is okay. We will HDFS. We need to learn about the Hadoop architecture, and then limitations of this Hadoop. Advantages already we talked. What are the limitations of HDFS? That we talk, and then we do some practice after installing the Hadoop cluster. We are going to do some HDFS file operations. So for this, it will take 5 to 7 hours or something like that. Next couple of hours. Okay. Okay, the MapReduce will spend more and more time to talk about the basic features and then right from word count, and then I will be giving a lot of examples from different by taking the different domains data like say social networking data or financial data, some other data, some sample files, a real-time file that I'm going to provide, and then how to process it, how to write the programs for that, for processing different kinds of data. Okay, so that's what MapReduce is about. These two are very important, and then which needs to be available on Hadoop cluster means these two are available. Okay, compulsory. All other ecosystems are optional based on whether you are using that particular ecosystem. Okay, so you install it and then use it. Yeah, install it, use it later. But not all the time you are not using all these ecosystems. Some of the ecosystems for your business implementation based on what ecosystem that you choose to implement your business logics, you use that particular ecosystem. Next is Pig. Okay, so MapReduce means what you need. You need some programming expertise, either C, C Sharp, and Python, okay, and an R language or Java language, okay, Perl, PHP. Any of these languages can be used. Ruby also. So any of these languages can be used to write your MapReduce program directly. So because the Hadoop is written in Java, it is native, and then if you write the code in other languages, then you using the streaming APIs, you can execute that code, and then automatically the streaming APIs will convert the equivalent MapReduce jobs and then execute against the Hadoop cluster. So that means what you need in order to write the MapReduce program, you need some programming expertise, right? Most of the people are not from programming background. For that, not only for that, lot of other advantages of other ecosystems they have created this thing. Okay, which is kind of 95% of the work which is done by the MapReduce can be replaced by Pig. Okay, using a high level language like your SQL. Okay, one statement will do a lot of work. So you can do like 1:25 or 1:20 ratio. One line of Pig code will replace 20 to 25 lines of MapReduce code. So code maintenance is easy. High level languages so that everybody can learn very easily. SQL is easy then writing programs in Java, right? You need to know a lot of things when you write the code using Java. Okay, SQL simple, one statement. Select star from EMP where so and so, simple. For that you need to write 200 lines of code, Java code, right? So like that, the Pig is implementing on top of Pig. You are using a language called Pig Latin language, which is kind of a data flow language, like your flow of statements that you write to implement your business logic, PL SQL programming or T-SQL programming. As you write the logic in shape, and then you declare the variables, and then use that variable value in subsequent steps, and then modify it accordingly, right? Okay, so in the same way, okay, when you are open up the Pig sessions, a Pig session, you can it will store the values of the previous. We'll call them bags. Here variables are called bags. Okay, so it will store the data in the form of bags, and then the bags value will be modified by taking that value and then apply some transformation functions provided by Pig, like your SQL functions, sum of cell or like a substrate instead, and then Pig also is having some transformation functions using those transformation functions from Pig Latin language. Okay, so you can modify the data and then store the data in a new variable, so that okay, that's why it is called a data flow language. Very easy to learn. 5 to 6 days of with some programming experience or SQL experience, you should be able to learn in 5 or 6 days completely. If you spend, you can develop the product. You can develop your code on it. You can develop your products if you have some experience, previous experience of development experience. Okay, so that's what the Pig is about. Okay, so data flow language and execution environment for exploring very large data sets or small data sets. So MapReduce is working on a distributed file system, but Pig can work with both environments for preparing the POCs. So that's why data scientists, okay, and data analysts will use this Pig because it is having both SQL kind of features as well as programming features. So you can store the data. So SQL query, you run the query. In order to store the result of query, what you need to have some front end, some Java code or something like that. But here it is having a programming language. So you can store the the tables data in a bag, and then you can store that bag also into your file system, either local file system or Hadoop distributed file system. Pig runs on two modes, local file system mode and then Hadoop distributed file system. Based on the mode that you enter, it will extract the file from that particular file system. Right, local file system is Linux file system or Hadoop distributed file system. MapReduce works on only, yeah, okay, HDFS only, but this Pig can work in both modes. It can access the files from local file system, write the results to the local file system. It can, if you switch the mode into Hadoop mode, and then it can access the files from Hadoop distributed file system, write the results to HDFS file system. It will work on two modes. So, because why it is advantageous? Because you can take a sample data when you are kind of trying to implement your business logic, test your business logic by taking some sample data. Every time you don't want to like work on a big file, right? Millions of lines of code, millions of the data that you don't want to test it. It will take long time to test your logic. So sample files on local file system and then execute it easily once the flow works, and then you execute it in Hadoop distributed file system so that you can access the big files and process the big files. So that's what it is. Okay, a language called Pig Latin language, which is kind of a high level language like your SQL language. It is kind of a hybrid language, which is getting some features of your Java code and then some features of your SQL language. Okay, a data flow language and execution environment for exploring very large data sets. Pig runs on HDFS and MapReduce clusters and then local file system also. That is what Pig is about. Okay, we'll spend like couple of hours on learning this Pig language, Pig Latin language, and then how to write the Pig script to implement your business logics. We'll be comparing it when you are talking about Pig. We'll be comparing with the high features when you are dealing with structured data. We are comparing with MapReduce when you are talking about dealing with structured data, unstructured data, and semi-structured data. Pig features with high features, Pig features with MapReduce features. We'll be comparing them. So how easy you can do using Pig. Okay. Okay, Hive. The next ecosystem is Hive. Okay, which implements an RDBMS concept which is built on top of Hadoop. That means your SQL language will work here. SQL queries. Then that means DDLs, your DDLs, DMLs, and then query select queries. SQL query language. Be here. Okay, will work here. So it is because of the limitations of HDFS. In HDFS, what are the files which are stored on HDFS cannot be edited. By default, they cannot be edited. So because your Hive also getting the same limitations. Okay. So that's why that because HDFS is not editable. So because Hive is using HDFS for underlying storage of its tables data. That's why. So single row insert statements, updates and deletes will not work in the older versions of your Hive installation. That's why it is called a data warehouse. What is the concept of a data warehouse? Storing the data in a bulk way for multiple applications, right? So all applications data of an enterprise will be bringing together and putting in a data warehouse with an intention to take the data from that application, this application, and then analyze in a big way. That's the purpose of building a data warehouse. The data warehouse means, but you are dealing with only structured data usually, right? The structured data only. Okay, so the Hive is implementing a data warehousing concept. What is the concept of data warehouse? Write once and read many times. Your data is generated from some OLTP systems, in some other place, and then you bring in the data and store in a central repository. That's the warehouse concept, right? You bring in all the application data of an enterprise, and with an intention to join the tables of different database of different applications. So that's the intention of this warehouse. Okay, a distributed data warehouse. A distributed, why? Because Hive is built on top of HDFS. It is getting all the features of Hadoop. What are the features of Hadoop? Scalability, availability, reliability, cost efficiency, flexibility, failover mechanism. Okay, all these features Hive is also getting, so that you don't need to do disaster recovery. By default, it is taking care of everything, making it available all the time. Okay, so that's what a distributed data warehouse. For implementing the data warehouse, you see in all the environments, Hive is used mostly because everybody is using some way or the other a database concept, right? So on Hadoop, if your intention is to build a warehouse, compulsory you use Hive. So everybody need to be comfortable in Hive. Okay, so Hive manages data stored in HDFS and provides a query language based on SQL. That language that you use in Hive is called HiveQL. SQL, you can call them in a short form HQL. Hive query language. It is Hive query language is dialect of SQL. So your DDLs with little minor differences in syntaxes. Okay, a simple differences in syntax because it is built on top of Hadoop and then it is taking the features of Hadoop. That's why so some a little differences in the DDLs, DMLs, and then select query. There are some limitations in the select queries. We are going to talk about when you talk about Hive. We are going to talk about the differences between a traditional ANSI SQL, which is used in your traditional databases like Oracle, DB2, and MySQL, all the databases, and then the SQL used on Hive, the differences between. So that if you know the differences, and then if you are an SQL expertise, you are Hive expert. That's it. Okay, so performance, how you do the performance tuning of Hive applications because it is built on top of Hadoop. Okay, it is internally using MapReduce. Where to control the things. So that is performance tuning in Hive is different from a little different from a Oracle performance tuning because it is built on top of Hadoop, right? So you have to take all those considerations when you are implementing when you are improving the performance of your Hive queries. Okay, so we are going to talk about in detail about Hive also. Maybe Hive and Scoop goes together because Scoop is the tool which is used for importing and exporting the data. So for both Hive and Scoop, we will spend almost like 10 hours, 10 to 11 hours. To get the overview of this Hive, how it stores the data, where it stores the metadata, okay, where it stores the metadata. Metadata means table information, okay, schema information, and then how it stores the data on HDFS, where it stores the data in HDFS, what are the kinds of tables like managed tables, external tables, okay, partition tables, bucketed tables, okay, how to import the data into Hive tables because it is built on top of Hadoop, and then how you are altering the tables, how you alter the tables, what are the limitations there, and then okay, so in the traditional RDBMS, if you wanted to do some programming, what you have there, PL SQL language or T SQL language, because Hive does not have that feature. That's why. So now you are going to talk about UDF, user defined functions. So Hive also provides some functions like built-in functions like sum of cell, sum, min, max, substitute instead, okay, replace, upper, lower. These are the functions that you use in SQL queries, right? So Hive also comes with some package of these built-in functions. So if it does not cater your needs, you have to write your own functions, right? In the traditional programming languages like PL SQL and then T SQL in Microsoft SQL Server or Sybase, T SQL is used, right? Here you use Java language to write your built-in functions. There is a process to define those functions. Okay, so in Hive we are going to talk about all these topics in Hive. Okay, how to create different types of tables, what are the advantages of the tables. Okay, so some of the additional features of Hive over the traditional RDBMS, we are going to compare the things between a traditional RDBMS and Hive so that you will get a clarity. So like I said, if you are an SQL expert, you are Hive expert. Okay, so this ecosystem and then Scoop we are going to spend a couple of hours. Here I will give equal importance to the MapReduce. Will take little more hours, but I will give whatever you needed. I will give whatever is required to get started on Hive. I will give you more examples, and I will discuss about each and every topic in Hive. You are not going to miss anything. Okay, so the next thing is Scoop. So for Hadoop, bringing in the data and sending the data, right? Bringing the data in order to build the Hadoop architecture. You need some data, right, from the sources. You need to bring in the data. So you need some data migration tools. Okay, data movement. Okay, so between Hadoop and then the other systems. What are the tools that are used to bring in the data into data ingestion tools? Okay, you need some data ingestion tools to bring in the data into Hadoop architecture, right? Not only every time you use the copy command to copy the files from local file system to Hadoop distributed. So you have to use some automated tools which will be doing at a regular, they will be running at a regular intervals and then provide the data on the Hadoop architecture, so that your multiple ecosystems can access the data to do the process. Right? You need some data to do to process the data. So not only all the time you are using the copy from local or put statements to copy the data into Hadoop cluster. You have to use some automation tools. So like that, we will be using some of the, we are going to talk about some data ingestion tools like Scoop and Flume and Kafka. Okay, so these are the data ingestion tools that you are going to use to bring in the data into Hadoop framework. Yeah, scheduler, in order to schedule it to work, scheduler means you are scheduling the multiple ecosystem jobs. So we are going to talk about Wooji. Wooji is the workflow scheduler which is built on top of Hadoop. A separate ecosystem is built for implementing this batch processing. Okay, Wooji scheduler. We use Wooji schedulers on which you are going to run multiple ecosystem jobs in a sequence. Okay, to automate the things you use the Wooji scheduler here. Okay, so here Scoop is a tool, one of the data ingestion tool like Kafka and Flume. Okay, Scoop tool will be used for dealing with the structured data, only structured data. That means databases data. So the data from the NoSQL databases, because the data is stored in the form of tables there also. So MongoDB, Cassandra, MarkLogic, HBase, all these are NoSQL systems. So either from the NoSQL systems or RDBMS systems or Teradata, a distributed database. So from all these external sources, you bring in the data using the Scoop tool. You build the Scoop statement to bring in the data in whatever the format that you want. You want it in a sequential format, or a tab delimited file, or a comma separated file, whatever the way that you want, you can bring in the data by reading the data from the traditional RDBMS tables. And then you can do the other way also by using the structured files, a comma separated file or a tab delimited file. Okay, so you can use this data which is stored on HDFS, that file, you can use that file, okay, to load the data into a MySQL table or Oracle table or any other traditional RDBMS database. That is called export process. Import process is bringing the data from other systems, other RDBMS systems or NoSQL systems or enterprise data warehouses, and then bring in the data into HDFS file system or directly into Hive or directly into HDFS. Entire schema, okay, entire schema of that MySQL will be, it is building a table in Hive directly. Metadata along with actual data will be imported into your Hive, entire schema, all the tables. You can get in all the tables of a MySQL database or a single table into Hadoop, okay, or only data that I want. I don't read the schema. So that it will read the Scoop statement will read that particular destination database RDBMS table and then put the data in HDFS as a structured file, so that you can use that file for you are using the you can analyze that file using the MapReduce, or you can load that file into Hive tables at a later stage. So that's what Scoop is about. It is not doing only just import and export. So a lot of other commands are available. Okay, merge command is there, list databases, list tables. Okay, so incremental imports. Okay, and then lot of other commands are available in Scoop tool. So a lot of functionality is there in Scoop also. That's one of the very important tool which is used for data ingestion. Okay, bringing the data and sending the data. So that's what the Scoop is about. We'll spend a couple of hours on this too. Okay, 1 or 2 classes. But very simple tool, easy to learn, and then more powerful tool for bringing the data. Okay, that's what the Scoop is about. HBase means a different concept. It is a database. That means it stores the data in the form of tables. That means columns and rows. But it is not an RDBMS. RDBMS is what? RDBMS, in order to build an employee information database, employee information that you wanted to store in a database. So all the related table will be put under a database, right? A database. So you create a employee information database, and then after that you are going to build. You divide the data related to an employee into multiple tables in order to reduce the data redundancy, right? For example, like in order to build an employee information database, what are the tables might be employee details table, department table, address table, phones table, emails table, rewards table, skills table, okay, and then salary grades table. So that means maybe 20 and history tables. Like that, you will have n number of tables related to that particular database, right? So that means, so you are dividing the data into n number of tables. When you wanted to all the information of that particular employee, including the history, you are making joins between all these entities to retrieve the complete information of that particular employee. That means, so you are applying the joins. You are applying the joins. That means that's why it is called relational database management system, right? So exactly opposite to the relational. That is using the third normalization techniques. You are reducing the data redundancy there in a traditional RDBM. Here, it is also storing the data in the form of tables, completely denormalized, 100% denormalization. That means only one table will be there. One table will be there. Only one table. Okay. Columns are static in the traditional RDBMS. So when you want to put some data in there, you have to create as part of this, or like through alt statement, you have to add that column to insert some data into that particular table column. So here columns are dynamic here. Okay, the tables will become families here, and then the database will become a table here in HBase. When you are creating the database, a table here in HBase, okay, you mention the table name, which is kind of a database in the traditional RDBMS, and then all the tables will become families, and then which is the part of the table, which is the part of table definition. The columns are not as part of the table definition here. Okay, columns are part of the insert statement. That's why columns are dynamic. Data means dynamic, right? You can insert or not. That is up to you. So that means it is column. That's why it is called a NoSQL database. And means not only SQL. Now NoSQL means not only SQL database, and then a column oriented database. Then you have the data, and then you mention the column as a key value store, and then provide the value for it. Then you are inserting the data. That a different architecture, but it is a table. It is a table. In order to improve the performance drastically, they use this concept. Okay, so the creators are the Google again. So based on the Google's big table, which implements this NoSQL concept, all these NoSQL database come into picture now. The competitors are HBase and MongoDB, Cassandra, Marketplace. All will work independently as a separate clusters, or they can be using this HDFS architecture. So you can build, you can interface with HDFS. Okay, they can use the HDFS storage space in order to implement this distributed architecture, and then they can work independently as Hadoop, has HBase cluster, as MongoDB cluster or Cassandra cluster separately. Okay, a distributed column-oriented database. HBase uses HDFS for its underlying storage, so that it is getting all the distributed features, and then it supports both batch-style computing using MapReduce and point queries. Using the MapReduce, using the JDBC driver, you can access the tables data from HBase or Hive. So from MapReduce programs like Java program, from your Java program, how you interact with the traditional RDBMS MySQL table, and bring in the data, modify it, and insert the data. In the same way here also, from the MapReduce programs, you can access the Hive tables or HBase tables data, and then modify them, and then again load the data into your HBases using JDBC driver. You can connect to the HBase using JDBC driver from your Java code. Okay, so that's what you can do. Okay, so like your point queries also that you can work. Like your select star from EMT. Here you scan table. Okay, it has its own syntaxes for creating the table, manipulating the data, and then querying the data. It has its own query syntaxes. Very simple, easy to learn, and then static, because only one table, everywhere one table. Entire schema is considered as a one table here. So kind of thousands of columns can be there. In each row, you will have thousands of columns data, because all these tables will become families, and then you will be inserting all the family columns in one row. So that's why thousands of columns will be there. For each table, very high performance, which is implementing. It can be used as a OLTP. Hive, because HBase is used as a OLTP database. Hive is not OLTP, only database. Okay, at this point, it is not used as a OLTP database. Okay, RDBMS. HBase is a OLTP. So, your Facebook is using HBase for storing its messages. All the messages are stored in HBase. So that's why, because it is OLTP, and then spontaneous response. Hive is doing internally map reduce. That means, so it is not a low latency database, high latency. So it will take 30 seconds to respond. So that's why it cannot be used as an OLTP database, Hive, but HBase can be used as OLTP. So in milliseconds you will get the data from HBase, because it is using different daemon processes. When you are talking about the HBase architecture, we are going to talk about it. Okay, what is the architecture of HBase? What are the daemon processes which are making it happen to support for OLTP? A different daemon. So it is not internally using MapReduce for bringing in the data. It is using a different architecture to bring in the data. Now, yeah, columns and rows. Same columns and rows. In the data is stored in the form of H files. So each family data stored in H files separately. By extracting and then or by inserting also. You mentioned the column name, associated value. Column name, table name, row ID, and column name, and then the associated value. Everything inserts. So if you have 1000 columns, 1000 insert statements. Unlike your traditional RDBMS, you mentioned all the columns and then the associated value in one statement, right? Here, one column data is stored in only one insert statement. That is the difference here. You'll get excited. It is kind of very interesting. A different way, but it is a database. It is a table. Okay, so that's what the HBase is about. Okay, next thing, Zookeeper. Okay, Zookeeper is one of the ecosystem. Okay, which is also compulsory in the distributed architecture. Like your HDFS and MapReduce, Zookeeper is also not optional. Okay, you are not going to do any coding in this. Okay, so based on the size of your Hadoop cluster, size defines what number of nodes. Based on your size of the Hadoop cluster, you are going to configure these Zookeeper services in more than one data nodes. Okay, so that means the Zookeeper is managing in-memory file system, so that it will improve the performance of your Hadoop clusters. Improve the performance of your Hadoop cluster. It will be acting as a coordination service between masters and slaves for some of the ecosystems, and then it is used as a proper distributed locking mechanism. So your cluster speed will be increased, processing speed will be increased. Okay, Zookeeper service, and then in order to implement the failover mechanism, how the master names when the slave fails. So first identifier is this Zookeeper system. That's why in this distributed architecture, so compulsory Zookeeper is, there is no option to avoid installing Zookeeper. It is compulsory, like your HDFS and MapReduce, in when you are setting up a multi-node cluster. Okay, multi-node cluster. That's what the Zookeeper is about. We are going to talk about an hour or so about the Zookeeper, because Zookeeper is, now you are not going to do any practice on this. No, it is not coding related. It is a config, it is a system which is helping this distributed architectures to work together in order to implement the distributed locking mechanism, in order to act as a coordination service, in order to implement the failover mechanism. Okay, so fail-safe mechanism. So it is used for implementing all these important unique features. Okay, that's what the Zookeeper is about. And then one more thing that we forget, Impala. Impala is the database, because Hive is using MapReduce internally. That's why it cannot be used as an OLTP database. That's why on top of Hadoop, you need an OLTP systems, right? Directly into Hadoop, you have to bring in the data directly from the online applications. For that, they have implemented separately a different ecosystem which is equivalent to your SQL language. No differences in SQL. A little differences in the metadata, okay, but not in the SQL queries, or like how you insert the table, how you define the tables, how you alter the tables. Everything else is the same like your SQL. And SQL can be used in Impala. Impala is the database. It is using a separate shell. We are going to talk about, and then we are emphasizing more on SQL there. Okay, the difference is we are emphasizing the more on differentiating between Hive and then Impala, how it is different. Okay, and then what are the limitations of this Impala over the traditional RDBMS SQL? So it is an OLTP system. We are going to talk about that Impala. I did not mention here that OLTP. That also we are going to talk about Impala. Okay, and then after this we are going to talk about UG. UG is kind of a schedule. So we talked about Hive, we talked about Impala, we talked about HBase, we talked about Pig, we talked about MapReduce, right? So you write the code for each of these individual systems. You develop the shell scripts. You develop the scripts for building your schema DDLs for in Hive. You write the MapReduce program to run them individually, but you wanted to run them one after the other to implement your batch processing, right? In the data, in this Hadoop architecture, once you automate the systems, there is no manual intervention, right? Your data will be coming in, some cleansing jobs will run, MapReduce jobs will run, and then generate a structured data file. That data file will be used by a Hive script to load that Hive table. That means unless that MapReduce job runs, you won't get the data for Hive, right? That means a dependency is there. Then you are making dependencies between the systems. Okay, yeah, and then in order to implement the batch processing, they have created a separate ecosystem called UG, which is kind of a system for running workflows of dependent jobs. It is a system for running workflows of dependent jobs, multiple dependent jobs. Okay, so that means you define a flow through workflow.xml. We are going to talk about this system. Okay, like multiple ecosystems jobs will be run. So you can copy the file which are in your edge node and then to Hadoop distributed file system. The next step is what? The next subsequent job is what? Running some clean jobs using MapReduce code. After that, and then run a Hive script so that previously generated data sets will be loaded into your Hive tables once the schema is built. Okay, so you run the you schedule all these multiple ecosystem jobs in a sequence. You write the workflow in order to define your end-to-end flow of your systems. Because so all these ecosystem jobs will be run in a sequence. You define the dependency in the workflow.xml. So using the XML, you define the flow of multiple ecosystem jobs. So that one after the other, they will run, and then finally update the destinations, and then you will get the data ready for the business users, BI tools, either Tableau or Kibana if you are using Elasticsearch. Okay, get the data ready for the Elasticsearch so that Kibana can access the data from Elasticsearch. Okay, like that you can use some of the third-party tools for providing the data for the third-party tools from this by implementing this batch process. Okay, so finally you get the data required for the users to access that policy data, finished data, completed data. Okay, so for that reason you are going to use UG, and then how to define the workflows, how to run them to execute immediately or schedule them to run at a specific intervals. We are going to talk about all those intervals, okay, on UG. We are also going to spend a couple of hours on how to write the workflows, how to run them, what are the prerequisites required to run the UG system. We are going to talk about the architecture of UG, how it works, what are the basic components of UG architecture, and then we are going to run a sample workflows which is having MapReduce jobs, Hive jobs, Pig jobs, scoop import and export. I am going to explain about the configurations required to run each of these ecosystem jobs. Okay, UG scheduler. That is about the UG scheduler. Next is Flume, which comes under a data ingestion tool. You need some data in Hadoop, right? So for that you use what are the tools that we talked before? Scoop tool, which is dealing with only structured data. That every time you have to initiate that scoop statement. You have to initiate that scoop statement. So to do a specific implementation, either import or export or whatever. Either query the database to bring in some data, like that. Okay, but Flume will be used for all kinds of the data: structured data, semi-structured data, unstructured data, either from the static source or a dynamic source like log servers. Your database, when it is running, it writes the logs, right? If you wanted to analyze that logs, incremental data you can bring in using this Flume tool. And dynamic data, read a file and then create a small files, events, called events, and then put it in your multiple destinations. You can send the data to Java messaging services, or you can send the data to your HDFS file system or different destinations. You can different sources, different destinations. There, the Scoop tool only designed to work with databases. Structured, it is unstructured data, but dynamic data, static data, dynamic data, or streaming data directly from your online, your program output, it can take. Okay, programming generating the output, it can take the output, and then you can bring in the data from a social networking site. It is getting generated there for your user account. You are bringing the data, okay, from a social networking site, from your Facebook or Twitter. That directly that data that you can streaming data can bring in, and then the destinations can be anything. Okay, a destination can be a online streaming system like your Storm, okay, like your Storm or Spark. Spark can do online streaming, right? Spark is the system which can do Spark streaming, MLlib, Spark graphics, Spark SQL. All these systems are implemented in Spark. So it can, Flume also can provide the data to Spark directly to get the streaming data, or directly the destination can be an HDFS or and then a Java messaging services. Destination can be anything, sources can be anything. Okay, either streaming data or dynamic data or static data. So you define the agents here. Each agent is configured to connected to a particular source and bring in the data, and then send the data to different destinations like a Java messaging service. You can send that data to a Java messaging service or HDFS in a specific directory path. You can store it in HDFS. That way you can bring in the data using this very important, okay, a reliable tool, a distributed reliable Flume cluster. Okay, a distributed reliable and available service for efficiently collecting, aggregating, and moving large amounts of data, either log data or streaming data or static data, anything. So you use the commands provided by this Flume tool to make the configurations, okay, for bringing the data from different sources and send the data to the different destinations. You are going to configure the agents here. Each agent will have its own architecture. Okay, so we are going to talk about the architecture of this Flume. What are the basic components of a Flume agent? Like that, you can configure multiple agents in a configuration file, so that when you run that configuration file, automatically all these, when you initiate that, each agent will bring in the data and send to the destinations. And then one-time triggering. When you specify the intervals in your configuration files, it will keep on running. You won't close that session. Once you open that session is active until you fill it, or until you stop it. It will keep on running at the regular intervals. It will connect the sources and then keep on working, bringing the data and putting in the text, and putting in your HDFS or Java messaging services a different destinations. Right? It will name the files. It has a naming convention. By taking the system times up, each file is named by the system automatically. Flume system at different times. You see on the specified directory in HDFS. Once it is configured, the Flume tool is configured, automatically you will see n number of files in that particular specified directory, so that you can use those files for doing the analysis. That way, you use this Flume data ingestion tool for bringing the data from different sources and send the data to the different destinations. Flume tool. Okay, that's what it is. Flume tool. One more system, Spark. Okay, so MapReduce, there are some limitations in MapReduce. Okay, when you talk about the MapReduce, that is a good point to discuss about the differences between MapReduce and then Spark. There are a lot of advantages to Spark, and then they overcome all the limitations of this MapReduce framework. Okay, so that's why they have to create this one to make these systems very faster. Okay, Spark ecosystem. We are going to talk about the Spark also. Okay, so we are going to talk about the Spark also, in couple of hours, but not in detail. Spark means you need to learn some languages also, Scala language, Python language. It will take, so you know that, right? For learning a language, it will take a lot of time. So I just give you overview how it will work. Okay, how you use Scala language. So how you use the functions of your Spark language to build the Spark streaming. Yes, Spark. Directly on 4.7, it is not available, but you can download the parcels and then install it. 5.7, it is already comes with Spark, like any other ecosystem. Directly Spark is installed. Here, using the parcels method, you have to build that. I will show both of the methods. Okay, how to build using the parcels in 4.7 version, and then in 5.7 you don't need to do this. Directly, when you type it in, okay, Spark shell, it will initiate the Spark shell so that it is installed. Okay, you can see the status of the Spark daemons. Okay, so that's what the Spark is. We are going to talk about a couple of hours on Spark also to understand the either overview. It is kind of an overview. I will execute one program and show it to you how it works. What are the internals? What are the RTDs? And then that kind of introduction session. And then some programs I will go ahead and execute. I will give you the environment for exploring more and more. If you are able to do it by yourself, you can learn, or otherwise come to my next class for Spark. Okay, so that's what it is. Okay, next integrations, because you learn about lot of ecosystems, right? How to make the integrations. Okay, Hive and HBase integration. Okay, Hive and HBase integration. Okay, so Hive and HBase integration. So because Hive is a RDBMS database, HBase is a NoSQL database, because both the similarity is what both are storing the data in the form of tables. That means columns, rows. Both are having columns and rows. So we can map the between the Hive columns and then RDBMS with the NoSQL column and then HBase columns, and then both tables will be in sync. When you insert the data from Hive, that data is reflected in HBase. When you insert the data in HBase, that data is reflected in Hive. That's what this integration is about. Okay, once you do this integration, automatically those tables, both the Hive table and HBase tables, will be in sync, related to keeping the same data in both ways, but it has its own query language, and then Hive has its own query language to query the data. Okay, so we are going to talk about those integrations, MapReduce and Hive integration, and then from MapReduce programs, how you interact with Hive tables using the JDBC driver, and then modify the data again, load the data into your Hive tables, and then MapReduce and HBase. Okay, so using the MapReduce program or Java program, how you access the HBase tables, modify the data, and then again insert the data. All these kind of internally you are kind of interacting with multiple environments. That's what the integrations is about. Okay, so we are going to talk about these integrations. So like that, so from BI tools, how you integrate the data. Okay, so latest versions of all these BI tools like the data storage and the MicroStrategy, SAS tool, which is a reporting tool, right? Tableau, you have RapidMiner. Okay, so all these tools are in Kibana. All these tools are kind of BI tools, business intelligence tools. Finally, you put the data either in Hive or Impala or like Apache Drill, right? So the data needs to be queried from this database from the business intelligence source, and then they represent the data in the form of reports or some other ad hoc queries from our BI tools. Okay, how to do these integrations? I have integration, SAS and SAS integration. I have a process because I provided some training through SAS, and then I taught SAS and Hadoop integration. For that, I taught the end users, the participants, Hadoop, and then SAS and Hadoop integration. So I am going to show that also, SAS and Hadoop integration. Okay, from BI tools, how you interact with Hadoop tools. Hadoop tools means Hadoop ecosystems like Hive, the data, how to run MapReduce program from SAS tool, from SAS environment, how you run MapReduce program and bring in the data, process the data, how you run a pitch script and then take the data, how you run a Hive query and then get the data into your BI tools. Okay, we are going to talk about that. We take one of the BI tool and then talk about the integration. These are the things. So I did not mention in the curriculum, it is optional. Okay. So but we are going to talk about one integration so that it will be helpful. MongoDB is not included in the syllabus. We can talk about it. I know MongoDB too. But so separately, if you wanted to learn MongoDB, it is kind of a vast. Lot of interfaces that you can how to integrate MongoDB with HDR. Hadoop. Yeah, I will show you that. How to NoSQL database. MongoDB, Cassandra, these are all the NoSQL databases. Smart Logic, all of the NoSQL databases. Okay, we are talking about one NoSQL database HBase completely, but integration we can talk about MongoDB and HBase. Database we are talking including this other, but Impala we are going to talk about. Oh, one okay OLTP database, one non-OLTP database. Okay. So that also we are covering everything what is required for you to get explore on the other ecosystems. You get that knowledge by that time. You don't even ask me, but we can do that because I already did that. MongoDB and Hadoop integration I already did that. Okay, with your interest, so I can provide that also. Okay, but not in detail because it is kind of a big thing. Okay, so we are going to do that. Okay, so this is the syllabus that we are going to cover in this curriculum, and then tomorrow is going to 8:53, 7 minutes left for our class. That's it. So that's why we are going to talk about a separate class on Monday on Hadoop architecture. So try to be here, everybody try to be here. Very important class, Hadoop architecture. Very interesting thing. How Hadoop works. How Hadoop works. Like how stuff works, right? You saw that website? Yeah. How Hadoop works. Huh? Weekends, huh? Yeah, every availability in this class is designed to run on weekdays, right? So if you wanted to 7:30 to 9, I am open morning time. I don't have any classes. I have a UK session which starts at 12 o'clock. Up to 12 o'clock on Saturday and Sundays I am available. I have a 4 hours class on weekends for UK people because of the time zones. So morning I am available. If I can check with them on and off, you can have the classes on Saturdays. Not on a regular basis, but I will check with everybody based on their availability. We can have on Saturday. Sunday we'll keep it because so we'll be continuously working on the things, right? You have to do the practice. You won't get time to do the practice. You keep on running and then you don't get time to do the practice. Yeah. We can do that Saturdays on and off. If you miss class anytime in the weekdays, based on my availability, most of the participants' availability, or some holidays or something like that, we can have a backup sessions on Saturdays too. And then based on their availability on Friday, I can check. And then if you are available, I can complete the session very quickly, right? But at the same time, you should be like following the things, right? You have to have some time to do the practice too, based on your tight schedules. We'll do that on Saturday, on and off on Saturdays. Okay. So any questions so far on Hadoop ecosystems? Tomorrow we are going to on next class on Monday. I will schedule for all the people on Monday so that make yourself available on that class. Very important class. We are going to talk about Hadoop architecture, how these daemons will work to implement this distributed parallel processing, and then to implement distributed storage. Okay. Any questions? Okay. Oh, okay. Amol might be, he is having meetings, right? He left. Amol Mehta, one of the directors in American Express. He left just one few minutes ago. Okay. So any questions so far? Because it is kind of clumsy. We talked about all the ecosystems. You need to get an overview. That's why I am introducing all the ecosystems and then kind of discussing about the syllabus also, what we are trying to cover and of each of the ecosystems. Okay. Tomorrow, in our next class on Monday, we are going to talk about Hadoop architecture. Any questions? Ravi, Shashanka, Trived, Vinay?
No questions.
No questions. Okay, good. So is it clear? Are you getting the things?
Yes, it is.
Okay, good. Okay, have a good day, weekend, guys. We'll meet you on Monday at 7:30 a.m.
Good
Okay.
day.
Okay,
Thank you.
thank you, guys. If you have any questions, queries, you can send me an email. You have my email ID, right? Okay. You have my phone number also in my signature. 9866885516.
Thank you.
Okay. So you are very welcome. Have a good weekend. See you guys on Monday, 7:30 a.m.
Okay. Okay.
Thank you.
Okay, bye.